Hello, I'm Vedant B, a fifth grader in Ms. Gianetti's class at Anne McCormick Sullivan Elementary. This is my science fair and GT project, wheels friction on a surface. My problem is, how does the material that a wheel is made of affect its distance traveled on a certain surface? This experiment answers that question. I researched on Mars rovers because with the growing humanity, many efforts are being made to put robots in space, and especially on celestial bodies like Mars and the Moon. You can see some pictures here, one of the complete rover wheels and the complete rover skeleton. The hypothesis is that the rover with wheels covered in aluminum will have the most distance traveled due to aluminum's low density, low weight or lightness, and a relatively low friction coefficient. On the right, you can see the Sojourner Mars rover, or the first rover on Mars. These are my variables. The first variable is the one that you purposely change, or the material being tested in this case, plastic, steel, and aluminum. The dependent responding variable, or the second variable, is the thing you are going to measure in the change. In this case, it's the distance being measured. The constant controlled variables are the variables you must not change. In this case, the push force relatively equal all 9 trials, and the type of simulated terrain. These are my research notes and bibliography. On the left, you can see Spirit, the second rover on Mars. On the top right, you can see my notes. I learned that the latest model of the Mars rover, Perseverance, uses a rocker bogie system for better suspension to help it stabilize on the Martian terrain. I also learned that NASA is using a new material working with the U.S. tire industry to have better stability on the Mars rover and for it to withstand higher damage. On the bottom right, you can see the websites that I used. These are my materials that I used for this project. These are a few pictures that you can see. The rovers with wheels covered in plastic, covered in steel, and covered in aluminum. These are my procedures. For safety, wear goggles to prevent sand from entering your eyes. You can see Opportunity, a twin rover to Spirit and the third rover on Mars. Here's my data table. The averages that the plastic, steel, and aluminum wheels on the rover went were 29.21 centimeters, 22.86 centimeters, and around 32.17 centimeters. On the top left, you can see Curiosity, a bulky SUV-sized rover and the fourth rover on Mars. These are my graph recorded with the averages of the 3 materials used in the rover wheels. On the left, you can see Perseverance, the latest model of a Mars rover. It uses a rocker bogie system, nuclear battery, and is the 5th and final rover on Mars to this day. The hypothesis is accepted because the rover with wheels covered in aluminum traveled the furthest. My evidence is that when I pushed all 3 different types of rovers down, aluminum wheels traveled the farthest. My evidence supports my accepted hypothesis because aluminum has several characteristics like low density, lightness, and low friction coefficient, making it very easy to propel. Some may think the hypothesis is rejected because of human error, but the data shows that aluminum has low friction coefficient, density, and weight, contributing to the high distance traveled. In the future, I plan to study more about the new material that NASA is using to create their new Mars rover wheels, a shape memory alloy called nitinol, and how its advantages and disadvantages affect the Mars rover. I will also research more about the rocker bogie system used in the structure of the Perseverance rover and how it helps the rover function. On the right, you can see a Martian wheel created from nitinol. That concludes my presentation. Thank you for listening and for watching. Have a good day.